All right, why don't we get started again? So I'm going to pick up now with there's a base class plugin that's called ND plugin file, and it's a base class, and then there are derived classes that are for each of the specific file formats. But the base class implements three different modes of saving the data. You can save a single array per file, or you can capture n arrays in memory and then write them out either as a single large file for file formats that support this, or to a bunch of individual files for file formats that don't support multiple arrays per file. Or you can stream arrays to a single large disk file. And for file formats that support it, the file writer stores not just the ND array data, but also all of the attributes. But some file formats don't support the attributes. The ones that do are the TIFF plugin, where it writes them as user-defined tags in the TIFF file, the HDF5 plugin, the NetCDF plugin, and the Nexus plugin. So those let you store the attributes in the file, but JPEG, for instance, does not. So the file formats that it supports is TIFF, and with TIFF, it supports any ND array data type. TIFF supports any of those data types. You need to be careful because many TIFF clients don't support a lot of the data types. For instance, I think IDL can read any of them. At one point when I tested, the Python imaging library could read most but not all. And as I say, it stores ND attributes as ASCII user tags, so they're stored in text. There's a JPEG plugin with compression control, NetCDF plugin. NetCDF is a popular self-describing binary format supported by this group at the University Corporation for Atmos Research in Boulder. And then there's an HDF5 plugin, which writes files with the native HDF5 API, unlike the Nexus plugin that I'll mention on the next screen, which uses a different API. They both write HDF5 files, but through a different API. It supports compression, and with the HDF5 plugin, there's a default layout for where the data goes in the file, but if you want to control the layout, you can create an XML file that says, you know, this is where this attribute should be put in the HDF5 file. This is where the data should be put, and so on. And it also now supports this single writer, multiple reader. So as Area Detector is streaming the file to disk, clients can be opening and viewing the file while it's being written. But that's only supported on certain file systems like GPFS and Lustre. It's not supported on NFS or SMB file systems, for example. And there's the Nexus plugin that writes HDF5 files, but with the Nexus API. This may be deprecated in the future because with the HDF5 plugin, in the appropriate XML layout file, you can create these Nexus files without having to use a different API and support a different library. There's ND File Magic that uses graphics magic to write files, and you basically just, by giving it the extension of the file you want to write, it automatically selects, writes a file in that format. So that supports itself, JPEG, TIFF, PNG, PDF, and a whole bunch of Windows bitmap, a whole bunch of other file formats. And then there's something called a null file format, which I'll just mention that.
On the previous slide,
yep.
You mentioned GPFS, NFS, and SMB is not supported for this single...
For Swimmer, right.
Why would that...
I think it has to do with locking, right? How the file systems implement locks. Or cache or something. I'm not sure. I just know what they say. I mean, it works on any local file system as well. It just, for networked file systems, it works on GPFS and Lustre, but not NFS and SMB.
Okay, so GPFS works, but not NFS. NFS, I don't understand why it would not work. like normal file.
It's like a normal file, but I think it has to do with something about the granularity of locking or guaranteeing that you flushed the cache.
Okay.
Because in order for this swimmer to work, it basically has to, when the client says, I want to read the file, the file writer has to, first of all, it has to be notified, right, that happened, and then it has to flush everything to disk, so you're sure that that what's on disk is a coherent snapshot. Okay. So in addition to the plugins, many vendor libraries also support saving files, like the Pilatus and the WinView and Lightfield and so on, and Area Detector also supports that. So your driver, through the same set of PVs, you can tell the driver to save files, and not just the plugins. But not all drivers support saving files directly. Many of them you have to go through a file-saving plugin, and you can use a file-saving plugin in addition to or instead of saving files with the vendor's library. The nice thing about using the plugins is that usually the vendor library doesn't let you put any additional metadata into your file. So you couldn't capture where were the motors or that sort of thing. There's other reasons you might want to use the plugins. And if you want to do the metadata, in many cases, or some cases, you might want to use the vendor file format, file saving, for real offline data processing, because that's what the user's analysis software already expects, is a particular vendor file format. But then you could write little thumbnails with a file plugin that aren't very big, right? They're binned 16 by 16, so they're just a little thumbnail, but they have all the metadata. So that would be a way to work around the fact that the vendor files don't support metadata. So this is just an example of the TIFF file plugin. So you select here, are you in single mode or capture mode or stream mode? If you're in capture or stream mode, you can say how many frames do you want to capture before you stop, and then you start it here. You give it a path, a file name, a file number. You can control whether this file number is automatically incremented each time the file is saved. And then you give it a C format string that puts together this, and this with any other characters you want to put into the file, and also specifying exactly how do you display this number. You could do %5.5D, and now it would be 0001, 0002, and so on. I think there is this option here to delete the driver file. So let's say you're using the Pilatus driver, and the only way to get the data into Area Detector is through their writing a TIFF file. Area Detector reads the TIFF file, and now you've resaved it as another TIFF file with metadata, or an HDF5 file or something. At that point, you don't really need the original driver file anymore. So if you set this flag to yes, and you have an attribute attached to that image that gives the complete path to the original file, then once this has successfully written it, it will delete the original file. And this can be very useful because, like with the Pilatus, it's typically using a RAM disk to save the images because it's so fast it can't keep up with a hard disk. But the RAM disk has a limited capacity, so there's no sense keeping the original TIFF files around, and you can delete them and run for longer before you fill up the system. This is the HDF5 plugin where you can select. It has several types of compression. In fact, this is an old slide. It now supports BLASK compression as well, and there's lots of options for how and this is where you can give it an XML file that defines the layout of the HDF5 file. And this is an example. probably pretty hard to read, of one of these XML files. But basically, you're telling it here where to store the attributes, and you know which particular attribute to store where in the file, where to store the images, and so on. So you can completely control the layout of the XML of the HDF5 file via this XML file. One of the things that I mentioned is that you can now have most plugins support running multiple threads. In fact, all the plugins where it really makes sense to do that, which can improve the performance of the plugin significantly. So in the tests I've done, throwing at least up to 5 threads in a plugin was a linear increase in performance. The maximum number of threads that you can use for a plugin you set in the constructor, but the actual number of threads to use can be controlled at runtime up to that maximum value. Plugins needed to be modified to be thread safe for multiple threads running in a single plugin object, but that's been done for all the plugins for which it can be done. When you have multiple threads running in a plugin, they could all be running at slightly different rates, and so the output arrays wouldn't come out in the right order. So now there's an option to sort the output arrays so they are sorted by their unique ID. This adds a little bit of additional latency, and it's possible that the next file you expect, or I'm sorry, the next array that you expect will never arrive because it was dropped earlier on in the plugin chain. So it has to have a timeout to say, give up after a certain amount of time. So this is that was the simplified version of the plugin base class that I showed earlier. That now, because we've added a bunch of new features like maximum number of threads and sorting and everything, this is a more detailed screen that you can drill down to here. But hides some of the complexity from the user most of the time. This one is intended to have things that are commonly used. This is less commonly used. But now you can see you can dynamically change the size of the queue here. This is really important if you've got let's say you want to run a detector and collect 2,000 frames really fast and save them to disk, but the disk writer can't keep up. So you can just make the size of the queue be 2,000, and now the camera writes, just puts them into this queue, and then the camera's done, but now the file writer is emptying the queue and finishes writing the files. And you can just dynamically change that number. You got to be careful, though, that you don't consume all the memory in your system and bring the system to its knees, which is why you have that option when you create the driver to say, this is, I only want to use 12 gigabytes of memory, and if this goes beyond that, generate an error. It doesn't allocate, this is only a maximum, so it doesn't actually allocate the memory until it's needed, but it is you can limit it. Any questions? Okay, so this was an example where we've got a statistics plugin where the detector was generating, I think, 500 frames a second, but the statistics plugin was only able to do 120 frames a second with one thread. And you see that this is the display of top -H on a Linux system, showing me that the simulation detector is using about 58% of the CPU, but the statistics plugin is using 99.9% of the CPU. So this is dropping frames because it can't keep up. But now if I increase that to 3 threads, there are now 3 statistics plugins running. It's able to do 384 frames a second, but each of these 3 threads is still CPU bound. But if I increase this to 5 threads, now there are 5 statistics plugin threads running, each one only using 86% of the CPU. So they're now keeping up, and the queue is not filling up. And it's doing 482 frames a second. So this is the list of plugins that have been modified to be able to support multiple threads. So the FFT and the region of interest and the statistics plugin you just saw, transform plugin. These are the plugins that don't support multiple threads. Most of these are ones for which it doesn't make sense because it's not CPU bound ever. You know, the file writing plugins are never CPU bound, they're file bound. And most of these, they aren't CPU bound. The one that is the plugin process, but that one, it's very difficult to make it thread safe because there's a recursive filter that's storing the previous frame. And if you have 5 threads running, which is the previous frame? You know, it's basically a very difficult problem. I think it's
as of release 3.1.
I think it's 3.1.
3.1. Okay.
Yeah.
And as far as the area detector, there's Core has the documentation says that there's release 3.2, but there's no release 3.2 in there.
Yeah, I usually update the documentation, but if you look in the release.md, it'll say the release date is January XXX. Okay. So that means I'm trying to keep the release notes up to date for the next release, but until there's a real date in that field, it hasn't been released. And git tag will tell you that it hasn't been released. Right? So I'm working on it. In fact, it should be soon. I don't know of anything else besides getting the make files to automatically generate the OPI files. That's the only thing I want to finish before I release 3.2. And
what are the new features in 3.2?
we can go look at the release, the release.md. One of them I know is the BLOSK filter for HDF5. And that was done by, I don't know how you pronounce his name, like, he's at the Swiss Light Source, Chinese name, begins with X. I don't know. No, it's a long one. Qing Guang, I don't know how to pronounce it. I'm embarrassed. Anyway, he did the BLOSK filter. Viewers. So there are a number of generic viewers. There's an ImageJ one that uses channel access. There's a new ImageJ one that uses PV access. And I mentioned the FFmpeg server that lets you look at images in any web browser or with VLC. And then there's also an FFmpeg viewer that is something that Diamond wrote that's Qt-based for displaying these MJPEG streams. So this is the ImageJ NT-ND array viewer. So you see it's looking at 13 Sim1 PVA1 instead of Image1, which you probably would have seen with a channel access viewer, but very similar interface. But it's a cleaner design because it's using the atomic NT-ND arrays instead of channel access with waveform records. So the advantage of this is that it's channel access. You need separate PVs. You can't with channel access. You define the data type of the waveform record at IOC init, and you can't change it at runtime. And that's a real problem because if you want to be able to view both 8-bit images and 16-bit images and 64-bit double FFTs, then you would have to make the waveform record be a 64-bit double. But when you're displaying 8-bit images, you're paying a factor of 8 penalty in network bandwidth. So PV access, the data type of the NT-ND arrays can change dynamically. So there's no restriction. Channel access, this was what Kaz was mentioning, this EPICS CA max array bytes. You have to set that. It's often a source of confusion and frustration for users because you don't want to set it too big because it actually allocates arrays of that size. But with PV access, you don't use it. EPICS CA max array bytes is not used. There's no restriction on the size of the NT-ND arrays. There's another viewer that's called EPICS AD Controller. So this allows you to use ImageJ ROI tools like the rectangle and the oval to graphically define the readout region of the camera or the position and size of an ROI or position and size of an overlay. And the plugin chain that you're looking at in your viewer can include things that, select an ROI or rotate or flip the image, and the plugin correctly does the back transformation of the geometry to take your mouse position and convert it into whatever coordinate system the plugin or driver that you're modifying is using. Finishing up here, there are other drivers that use AD core, not just area detector, because ND arrays are not limited to 2D detectors, and lots of these plugins, like the file and region of interest and statistics plugins, are useful for other kinds of detectors. So, for instance, we can use it for spectrum arrays, where it might be, the number of multi-channel analyzer channels by the number of detectors by the number of pixels. That's used for the Express-3 from quantum detectors. It's used for the XMAP, the Mercury, and the Falcon from XIA. It's also used for time series data, for the quad electrometer, for these electrometers from KINE-LS, and also for the electrometers that Pete Siddons' group here has built at the MSLS. So that uses, the FFT plugins, the file saving plugins. So you can take that quad electrometer data and just stream it to disk for an hour, and then go back and look for long frequency, low frequency drifts and that kind of thing. This is probably almost impossible to read. Yeah. So this is just showing the class hierarchy, and at the top is asyn port driver. The next thing below that is asyn ND array driver. So that's a class that inherits from asyn port driver, but it knows about ND arrays, and has the stuff for processing file names and searching for paths and that kind of thing. And then below that is ND plugin driver base class and all the plugins that derive from that, and then the AD driver base class and all the drivers that derive from that. But I could also display over here the quad EM base class and the drivers that inherit from quad EM, and so on. And others, like the group at Slack, has built a transient digitizer base class up here, and then real vendor transient digitizers inheriting from that class. So this is the last slide for this talk. The conclusion is I think this architecture works pretty well. It's easy extended to new drivers, plugins, and clients. There's nothing area detector specific about these base classes. You can use them to implement any kind of detector. And these are some links where you can get the stuff on GitHub. And at our website here, I maintain, or I will build on request tar files that are pre-built binaries. And people often want that for Windows because they don't want to set up a Windows build system. So, but I don't have a routine job that's running that. So let me know, and then I just run a little script, and it builds the latest tar and zip files for a particular architecture. Okay. Any questions? Comments?
The versions. Right now, I'm still running some old version of area detector.
Uh-huh.
Updating it to newest version is the big reason, other than the thread, multi-thread.
I guess probably mostly it's for the features that the plugins have. Say, the HDF5 if you want to use Swimmer. It depends how old the version is. Every new release. 1.9, there's been a lot since then, right? Like for instance, TIFF files don't store attributes in 1.9. Or I think they might store the timestamp and the unique ID, but no other attributes. So if you wanted to have attributes in your TIFF files, you would want the new version. Yeah, you just look through the release notes to see what's been added. Quite a bit's been added since 1.9. That was 2014, I think, right? Or the end of 2013. So it's getting on 5 years ago. So.
Would it be a proper moment to ask for a binary for Windows 7 for broken timer?
It's already done.
Oh, you have already?
Yeah, because somebody asked me that. Yeah, Chanaka asked me for that. So that's on the website. So if you in fact, let me just show you where to find that stuff, and then you can. So if we go to.
Are these binaries for the latest version with EPICS 4 or with an NTO?
Yes, and in fact, the Dexila that we were running yesterday afternoon, right? That was a pre-built binary.
That was a pre-built.
Right, and so if you go to Cars U Chicago software pub, and then you'll see subdirectories for each of the detectors. So if we go to AD, oops, what's happening here? Let me use the real mouse. AD Perkin-Elmer. So then these are the pre-builts, and so there's the releases here, right? So and these aren't always. It's not necessary. I made these ones on. Wait a minute. Is that right? That this was back in November? I thought we did this just the other day.
Well, Dexila you did.
Okay.
Recently, like 2 days ago, 3 days ago.
Right. Yeah, maybe I did this one back in November. It says it's 2.6. It might be 2.6 plus a little bit. In other words, that was the most recent tag. But usually, I build these from my master branch, right? So this is 2.6 plus a little bit. And yes, that would. I have to look.
Should be more recent, but.
No. Yeah. I have two different trees that I work with on my Linux system back there. One is the production system that's actually being used on the Beamline, and one is the development tree. And right now, the production system is using 3.15.5. Oh no, but both of them have v4, right? It turns out that when you make a static build, there's nothing that needs to go into that from v4 because it's statically built. So there's no DLLs or SO files from v4 that are needed. They're built into the executable. And they're from v4. There are no OPI screens. There are no databases. So you don't actually need anything from the v4 tree in a pre-built file. But it does support v4 because that library was linked.
And then the reason why it's 2.6, not 3.5?
No. Remember, okay, each repository has its own release. Okay, so this is 2.6 of AD Perkin-Elmer. But it doesn't tell you what version of AD Core that was. Okay. But I can tell you it's 3.2, okay. Even though 3.2 doesn't exist. Right? Yes, yeah, it's the latest. I mean, if I had more time, we could say what version and put AD Core number into this and make it a real release instead of just that release plus whatever's been done on the master branch since then. But usually that's not a problem. Okay, so now I got two more talks that are quite short, like 10 slides each. So let's look at this one. So this was about how to go about writing a new driver for area detector. So these are just some suggestions for how to go about doing it. Of course, first thing you need to do is to study the vendor API documentation. And then typically, the vendor will give you their own software, right, to run the detector. It might be a Windows program. And it's a good idea to run the camera with the vendor GUI to try to understand, fully how it actually works. Often, well, I shouldn't say often, not often enough, the vendors provide a simulation camera in their SDK. And when they do, that's really useful because it means you can start working on the driver before you get the hardware. You just have to download their SDK and run the simulation camera. And there are a number of vendors that do that. Princeton Instruments does a really nice job with light field. In fact, they let you simulate any camera. So you can say, you know, I'm simulating a EPICS camera or a I don't know, any of their models. So you can do quite a bit of work before you get the hardware. Probably the most important step is to try to find an existing area detector driver to use as a model. So it's worth spending some time to figure out which existing driver is most similar to the one that you're going to be writing. If the detector that you're using has a socket interface, then you should start with one of the existing drivers that uses a socket interface and not one that uses a vendor library. And it's also, just like we did in the example with ASIN yesterday, you know, I think it's a good idea to just figure out which features are most important to implement first. Don't try to implement the entire SDK on day one before you get it working. You know, just build as simple a driver as you can to show that you can collect the images before you worry about how do you change the gain and how do you change the binning and that sort of thing. And yeah, those last two bullets just say that. So this can be helpful for one of the bullets on there, which is figuring out which detector driver is most similar to the one you're using. So this is a list of drivers that come with a vendor library, with a C or C++ vendor library, and you know what the name of that library is, what operating systems it runs on, and what interface that detector is using. So if you've got a new camera that you know that needs to run on Linux, and you know you could choose from this list to find one that might be a good match for what it is, the camera that you're trying to detector you're trying to write a driver for. Then this is a list of drivers that don't use a vendor library. These are ones that use a socket interface. So the Pilatus, the MarCCD, the Bruker, the PixieRad, and the Photon Sciences. And then these are drivers where basically you're automating a GUI. So there was Lightfield was the one I showed you earlier, and WinView is a predecessor program to Lightfield. They're both from Princeton Instruments. So here's some, you know, guidelines or rules for writing a driver. So you'll, as we saw with the ASIN driver for the measurement computing yesterday, you know, the driver is going to generally implement one or more of the write int32, write float64, or write octet functions if they need to act immediately on the value of a new parameter. So for some parameters, it's sufficient to simply have them stored in the parameter library, not handle them in these functions, and then you retrieve them later. And we saw that yesterday in the measurement computing driver. If these functions are implemented, then unlike the driver yesterday, and we probably should have done this in the driver yesterday, is that they must call the base class function for parameters that they don't handle themselves and whose parameter index is less than the first parameter of this class, i.e. the parameters that belong to a base class. So if you're not going to handle a particular parameter, you need to call the base class with that parameter because it may need to handle it. And you try, you know, just like we saw yesterday, in your constructor, you're going to call create param for the additional parameters that you've created beyond those that are in ASIN port driver or the AD driver or the ASIN ND array driver base classes. A lot of times drivers are going to need to create a new thread in which they run the acquisition task. Sometimes you don't need to do that because sometimes the vendor library itself creates a thread that's doing the acquisition and you just specify a callback function that'll be called every time there's a new frame. But a lot of times you need to write a thread which calls some vendor function that says, please give me the next image, right? And it blocks waiting for the next image. So it needs to be in its own thread. And there are lots of examples that you can look at to see how to do that. So then that acquisition thread is typically monitoring the acquisition process, calling the vendor library saying, do you have a new image? Please give it to me. And then performing periodic static update callbacks. And the details of how to do that vary a lot depending on the specifics of the vendor API. But as I say, there are a lot of examples you can look at to figure out how it's been done in the past. One of the things that area detector supports is, there's two different numbers. There's the acquisition time, the exposure time, and then there's also the acquisition period. So you can say, I want to collect images with a 1 millisecond exposure time, but I only want to do it at 10 hertz. So there's two different numbers there. And sometimes the vendor API supports that they support a fixed acquisition rate. But if they don't, you should simulate it in your driver. So you do an EPICS thread sleep that waits for the time between the next period, so that if the user has asked for a 0.1 second acquisition period, you sleep to achieve that for them. And again, the SIM detector, Mars CCD, and other drivers have examples of how to do that. So there's a parameter that all drivers should implement, which is called ND array callbacks, which is so that you can completely disable your driver from doing callbacks to the plugin. That can be disabled because maybe you don't really want to use the plugins. All you want to do is control the detector and use the vendor file saving. So if this is not disabled, then you're supposed to do ND array callbacks. So what you need to do is for the last ND array that you got, you need to set the unique ID, you need to set the timestamp and the EPICS timestamp. You'll see there are two different timestamps. One is a double, which is very convenient. It's basic. EPICS timestamp is seconds past epoch and nanoseconds and they're two 32-bit numbers. That's what this is. So that's the highest precision timestamp you can have in the ND array, but it's not very convenient because it's two 32-bit numbers, right? You can't plot it and that sort of thing. But so there's also a timestamp which combines those two numbers into a single number that's seconds past epoch with a fraction. It's limited today to about a microsecond, right? Because that's how many bits can be in a double, which is probably good enough for many applications. Anyway, there's both of those. So then you have to call ND array driver get attributes, and that'll go and the user has defined some list of attributes, and that'll attach those attributes to your array. And then you call do callbacks generic pointer, which will now call all of the plugins with this array that you've now generated and put in the required metadata, additional data. And this last sentence, I'm taking this right out. That is a lie. Before I give this talk again, this was something that I thought I had observed a long time ago, that you could get a deadlock if you didn't release the mutex. But it turns out that's not true, and it's actually a really bad idea. So that's gone. We could do this now, or we could wait and do this later, where we actually study some drivers like the simulation detector or the MAR345 or the Perkin-Elmer, which are examples of 3 different types of drivers. I think maybe we should wait and let me finish the next talk, which is about plugins, and then you guys can decide what it is you'd like to do. Okay, so this is the last talk here, which is about writing plugins. So this is just a list of all the existing plugins and whether or not they generate new ND arrays or they're just a consumer of ND arrays. So plugins, the base class defines a process callbacks function, and that's basically what you implement. And so that's what's going to be called every time your plugin runs. So this is going to be called with an ND array pointer each time a new callback occurs, and you're going to call the base class process callbacks. In fact, this has changed. There's an initial process call, or maybe start process callback and finish process callback. So I got to update this slide, but it's basically correct. You just look at an example and you'll see what you do. In fact, there's two. There's one you call at the beginning and one you call at the end, which handles a lot of the common tasks. And then again, you're going to implement a write int32 or write float64 if you need to act immediately on a new value of a parameter. And again, this is just copied from the one for the driver. It's the same thing. If your function is implemented, then if you didn't handle that parameter, you have to call the base class with that parameter. Again, you have to call create param for any new parameters you define. Most importantly, you may never modify the ND array that you receive in the process callback function. It's read only. But that right now is not enforced by the compiler. You have to make sure you don't do it. The reason for that, of course, is that other plugins may be operating concurrently on the same ND array since they've all been passed the same pointer. It also means that you can't call get attributes directly on your array because that would modify the structure. So if you're going to change the attributes, you have to make a copy. So in ND array pool, there's a copy function and a convert function, which can be used to obtain a new ND array, which is either a direct copy of the one that you got, or convert does things like extracting a region of interest, reversing the direction. It can do some manipulations on the array. And they also copy the attributes to the new array. And yeah. One of the things that I would like to refactor in this is that a lot of times the plugin might have new attributes, but right now, if it's going to get new attributes, that would modify the array, so it needs to do a complete copy, even of the data. So what we'd like to make it is so that you can update the attributes without having to copy the data. But that's going to take using smart pointers in ways that we're not currently doing it, or switching completely to a PVA server, which would handle that for us with additional complexity. That's on the to-do list. But right now we're paying a bit of a penalty in copying when we really shouldn't have to copy all the data if the attributes need to be updated. So a really important thing here is that when the plugin is doing anything that's time-consuming, it's got to release the mutex. But it has to, because if they don't, the driver won't be able to access the queue in this plugin. So before it releases the mutex, it's got to copy any class data to some local place where it's thread safe, that there's no other thread that can be modifying that location. So that just before you release the mutex, you've got to make sure that while you don't have the mutex, you're not accessing any class variables, which includes the parameter library. So when the mutex isn't held, when you've released the mutex, you can't call get integer param or get double param, because that could be an act. You could have conflicts with another thread. And then if you produced a new array, then at the end you call do callbacks generic pointer, so that the register clients get the values of the new arrays. Okay, that's actually it. And I guess I'm open to suggestions at this point for what we do next.
Okay, there's a couple of things. I was thinking to look at the possible compilation of the area detector, but that might be time consuming.
Well, I can do it on my computer easily.
Right. Yeah, so we could try that, and then on your computer it might be faster because you already have stuff set up.
Right.
Do you have already the base 7, or you're
Yep.
still going?
Yeah. Right now I could recompile either.
7 takes a while to compile.
Oh, I wasn't going to recompile base.
It makes no sense to do the base, but I think area detector with I'm having problems, for example, with graphics magic.
Okay.
That one never gets implemented, or never compiles properly or something.
Really?
Probably it might be the way I'm doing it. I try to compile also FFmpeg from Diamond, and it goes into some kind of a weird loop that it's trying to compile itself several times or something like that, and also never finishes.
This is interesting. From Chorus here, should I be able to SSH out?
Would you need the VPN? No, VPN is only for inside the program. Going outside, you should be able to SSH. Yeah. It's like a normal Wi-Fi.
Okay. This is not connecting. Oh, there it is. It just took a long time. Maybe because, I don't know, was switching from my hotel network to this one or something. Okay, so here we are. So if I go to devel /area detector 3.2, so at this point, we've got all the drivers, basically the tree that I showed you there, and it's got AD support. Okay, so yeah, let's look at a couple of things here. So if we go to the configured directory here, and let's look at config site.local and release paths.local. Okay, so this is config site.local, which is what you edit. Well, first of all, you copy this from example config site.local, and then you edit it to be site specific. So build IOCs is a flag you can set that says when you build each of the modules, do you want to just build the library or do you want to build the example IOC as well? If you build the example IOC, then you have to have not only asyn and EPICS base, but you also have to have the modules that go into the IOCs like calc and the busy record and so on. You have to have built those. And then here is where you define all of those things that I was talking about. Let's ignore boost for now. That's used for unit tests. But below that is, with PVA equals yes. So that says you want it, if you don't set that, don't set it or you set it to no, then it won't build the PVA plugin and the PVA driver. If you want to use the BLOSK library with the HDF5 plugin, you do with BLOSK, and I said BLOSK external equals no, which means it'll use the BLOSK library that's in AD support now. And BLOSK is some additional compression stuff. With graphics magic equals yes, graphics magic equals no. I'm sorry, graphics magic external equals no. That means I want to use AD support. HDF5 equals yes, external equals no, JPEG yes, external no, NetCDF yes, external no, Nexus yes, external no. So it's using the AD support versions. But here I said OpenCV external equals yes, because you need to get OpenCV is not in AD support, but I said with OpenCV no, so it's not going to actually build with OpenCV.
To include it, you would have to have yes. And
You have to have yes and yes. That's right. SZIP, that's a compression that's used with HDF5. TIFF, XML2. There is no such thing as with XML2, but you can say is XML2 external, yes or no. And yeah, so that's what that file looks like. The other file here is release paths.local. So this, you define the path to support, which is where, asyn, typically where asyn and all of the modules like calc and busy and dev IOC stats are. Where's area detector and where's EPICS base. And then if with PVA is yes, then you tell it where to look for the v4 libraries. If you're using 3.15 or 3.14 or 3.15, then it would look something like this. It's EPICS v4, EPICS CPP 460. If you're using EPICS 7, which I am here, then it's in EPICS base / modules is where the v4 stuff is. Okay. And then let's look at, there's also release libs include. So this is where you tell it where the support, where asyn is relative to support, where AD support is relative to area detector, and so on. So you just edit this file. In fact, this file may be right, except you might not be using that version of asyn since it doesn't exist. Hasn't been released yet, but it will be 4.33 pretty soon. So those are the three modules that you need to include. The complexity can come, and hopefully, initially this should be fine. On my system, I'm building for multiple host architectures in this same tree. So I'm building for Windows in the same tree that I'm building for Linux. I'm building for Red Hat 6 in the same tree that I'm building for Red Hat 7. And they might have different flags. In other words, on Red Hat 6, I might be saying I want to use graphics magic external yes, and you can have config site.local.epics hostarch and make and that gets read after config site.local. So it'll first read config site.local, and then anything that's different from config site.local for a particular hostarch, you put in the hostarch specific file. Any questions?
Is there any advantage to doing the external build versus using the support?
Not that I can think of. And the disadvantage is that you might have an older version, of the library that might not work with, or even a newer version that is somehow broken backwards compatibility. And so if you use the ones in AD support, I can pretty much guarantee that they'll work. If you use the system version, it might or it might not work. It makes your executables a little bigger. Because typically when you use the external version, it's going to be dynamically linked. Actually, it depends. When you build an EPICS executable, you can say static build equals yes or static build equals no. So if you build it statically, all the libraries are built in. If you build it dynamically, it requires the SO files to be available at runtime. For Windows, I build statically wherever possible, because then I can just take an executable and put it on another Windows machine, and I don't have to copy 50 DLL files and have the path be right to the DLL files. On Linux, I often build statically as well, but you can build statically or dynamically. Yeah.
Can you try to compile the FFmpeg? Or where do you get the FFmpeg directly? Is it from Diamond, or you are getting it from the FFmpeg?
I have not done the FFmpeg recently, so I can't answer that question. Yeah, I haven't built the FFmpeg viewer. But if here we're at the top level of area detector, so if I do make -sj clean uninstall, and for those of you who don't know, make -s means do it silently, make -j means do it with parallel make. So it did the clean uninstall. So now if I do make -sj, well, first of all, let me see. Am I building for 32 or 64-bit Linux? So I'm going to do echo $. Can you guys read this? Okay. Echo EPICS host arch, so it's Linux x86 64, so I'm building for 64. So let's do make -sj. So this is down in 80 support, building the BLASK library, HDF5 library, and if I duplicate this tab, and is this going to take a long time to connect to? Huh, that's weird. I don't know why it's taken so long to connect. This has something to do with the Brookhaven firewall, I'm sure. So it looks like once the connection's up, it's fast. You know, it displayed, I was using X Windows to display the editor there, and it was very fast. But the initial connection here is really slow. Oh, I just saw a message there that it was updating some OPI files. So it looks like it already does descend into the op directory and build the OPI files.
But it built only for the 84, right?
Yeah, I don't know. I mean, I put that file in SIM detector as well, but I don't know if it's descending into that directory. And I'm not building. Oh, I am building SIM detector. Okay, so it's done. Okay, so that's rebuilt. You know, not only 80 core, but all of the drivers. This is a 20 core machine, so make -sj is pretty fast. Yeah. Yeah, there are warnings, but I don't believe there were any errors. And a good thing to do with make -sj is to do it again. Because sometimes, you know, if it failed, you might not have seen the error message, but if the second time it doesn't do anything and it's already done, then you know that it worked.
So if there are no questions, we probably should reconvene.